Hello. Now I'm going to explain second derivative tests and where do we use this test. So for values that makes first derivative 0, then the second derivative of f exists on an open interval, then we can say if the second derivative sign is positive at the value that makes first derivative 0, we have a local minimum, because if second derivative is positive, then we have a concave figure. If the graph is concave, then second derivative is positive and we have a local minimum point. Similarly, for values that make first derivative 0, if the second derivative is negative, then we know that the graph is convex. If graph is convex, second derivative is 0 and we have local maximum point. So this is the idea of using second derivative tests. First, we will find the values that make first derivative 0 and find second derivative and insert that value into the second derivative and see the sign. If sign is negative, then there is maximum, positive, then there is minimum point. What if the value that makes first derivative 0 makes second derivative 0 too? In this case, we will say test fails. It doesn't mean that there is no maximum, no minimum. It means it's inconclusive. We don't know what it is. We may have minimum point, maximum point, or neither of them. We have to use first derivative test to figure it out. Let's take a look at an example and use second derivative test to find minimum and maximum point. So what is a minimum or maximum point by using second derivative test? We can of course do this by the first derivative. Since our topic is second derivative, let's practice on that. So the first derivative is negative 2x minus 5, and when you equalize it to 0, what makes it 0? X being equal to 5. Now I'm going to insert 5 in the second derivative. What is f double prime of x? It is negative 2, just negative 2, right? So when I insert 5 back, it's going to be, since it's constant, negative 2. So the sign of second derivative is negative. If sign of second derivative is negative, then we have a convex function. If there is a convex function, then we can say there is local maximum. So there is maximum at x equals negative 2. Sorry, not x equals negative 2. At x equals 5. Local maximum at x equals 5. Okay. Let me revise the steps. Find first derivative, equalize it to 0, find x value, and insert the x value that you found from the first derivative into second derivative. See the sign. If sign is negative, there is convex function, then we have a local maximum point. If the sign is positive, then you have concave function. The sign is positive, like that. There's only one ministry exam question about this. 2024 second attempt ministry question. We are given the value that makes first derivative 0, and we are given the second derivative function. So which one is true for that information? So like we did in the previous question, we will take the value that makes first derivative 0 and put it back into second derivative. Okay, so what is f double prime of 5 pi over 3? Which is equal to 2 sine 5 pi over 3. So just evaluate that. Two sine 580 over 3, 300 sine 300. This is in the last quadrant whose sign is negative. So we have a negative second derivative. Negative second derivative means function is convex. If function is convex, then we have a local maximum point. So which option do we have? We have maximum here in option A. Even though you don't know it, actually, without solving it, while looking at the options, you can figure the answer out. Because in option C says there is local minimum, meaning we have concave function. Option C says function is concave, so B and C are same. So they cannot be true, both of them cannot be true at the same time. So answer should be A then.